So good morning, my dear friends. We are starting with today's class. Make sure that you are taking notes. Kindly make sure that the name and the roll number is written on the top right-hand corner of the screen. The topic under consideration, it is permutations and combinations. All right. So I am straight away starting with the session. The first thing that you all have to note, it is this. Permutation. Permutation. It's all about arrangements. Okay, make a note of this. Arrangements. And combination. Combinations. It's all about, can anyone complete it for me? Combinations. It's all about selection. Okay. So permutation, it's all about arrangements. Combinations, it's all about selections. So whenever the question it involves you people to deal with arrangements of items, there you will be considering permutation. Whenever a question it involves you people selecting items, there you will deal with combinations. So this is the first thing that you have to keep in mind while you are attempting questions. When P should be used, when C it should be used, you should have an idea. I will give you another example. Okay, imagine that there are 20 students. Okay, 20 students there. You need to select 5 students out of this 20, or from this 20 you have to select the 5. So in how many ways can you select 5 from the 20 available? It will be 20 available. You have to select 5. So it is all about selections. Selections means what? Selections means you have to consider combinations. So it will be 20C5. Okay, so make a note of this example. 20 students, you have to select 5 means it is this can be achieved in 20C5, that many number of ways. All right. Now, what is or how to evaluate 20C5? 20C5 is 20 into 19 into 18 into 17 into 16. Whole divided by 1 into 2 into 3 into 4 into 5. So 20C5, it is evaluated like this. Okay. Now you will be using these conceptual inputs for solving the practice questions that I'm going to share with you. The quiz I'm going to share with you. So make a note of these inputs very carefully. Okay. So with this intro, kindly remember NCR, it is equal to always NCN minus R. When I say NCR, always you should note that this R value, it will be less than or equal to N. Did you get me? Which means we cannot evaluate 15C20. I cannot evaluate that. But on the other hand, 20C15, yes, I can evaluate. 15C20, I cannot evaluate. Because for NCR, the R value that should always be less than or at the most equal to N. So that is another thing that you have to note. This point, what I said, it's going to surface when you are attempting a few questions. Okay. So that is another result. Also note, if I claim that NCP is equal to NCQ, if I claim NCP is equal to NCQ, please be aware, N it is equal to P plus Q. This is another result which we can use for solving some questions. Please make a note of this in our class assignment paper, which you are going to submit for me. Okay. Now, let us get into the first question now. We will do the practice questions fast, and then I will give you the practice quiz. Okay. So pay close attention to these practice questions. 25C12 is nothing but 25C12. This is nothing but 25C 25 minus 12. Can you tell me how much is this? 25C 13. So I can see that this 25C12 and this 25C13, they are equal. In the same way, I can see that 25C19, this is as good as 25C25 minus 19, that is equal to 25C6. So 25C19 and 25C6, they are also equal. Thus, if you look at the presentation here, 25C12, this is equal to 25C13. So when you do this, the result will be 0. In the same way, 25C19 and 25C6, they are equal. So this also will get cancelled off. So what is the final answer for this question? The answer will be option B, that is equal to 0. I hope the first question, it is clear to you. Let us go to the second question. The explanations I have anyway provided there. You can refer that. The next question. NC12 is equal to NC23. So from this I can say that N, it is equal to 12 plus 23. What is 12 plus 23? That is equal to 35. Thus I got the value for N as 35. Because the result says NCP is equal to NCQ, which means N, it is equal to P plus Q. That result I used. So you are now asked to find what is 37CN. 37C35, which is again as good as 37C, 37 minus 35. 2. What is 37C2? It is 37 into 36 whole divided by 1 into 2. Cancels of 18. We get 37 into 18. What is 37 into 18? Option C, 666. This is going to be our answer. Any difficulty in understanding this question, please? All okay? If so, let's go to the next question. The number of words that can be formed by using all the letters of the word Genesis, Genesis. Please tell me how many letters are there in this word Genesis? 7 letters are there. So all these 7 letters, they can be arranged in 7 factorial ways. But if you observe a little more closely, what is that you can observe? You can see E is happening twice. Do you see that? In the same way, you can see another letter is getting repeated. S, it is also getting repeated twice. So, considering a word which has got letters which is getting repeated, the number of ways this arrangement can be made, it will be 7 factorial divided by this 2 factorial is dedicated to the 2 E's, and the next 2 factorial, it is dedicated to the 2 S. So my answer will be 7 factorial upon 2 factorial into 2 factorial. Make a note of these steps, please. And then the answer will come as 1260, option C. In the class assignment that you are going to submit, make sure that you are writing it. Don't just listen to it. Please write it once. This is part of class activity. Okay. So that is for the third one. Everyone, please write this and submit the same towards the end of the class. The next question. Ahmedabad is connected to Bhopal using 4 highways, which means to travel from A to B, there are 4 ways. Then Bhopal is connected to Delhi using 3 highways. Now the question is, you have to travel from Ahmedabad to Bhopal and then Bhopal to Delhi. How many ways things can be done? The answer for this question is A to B and then B to D. Okay, A to B and then B to D. So it will be 4 into 3, that is equal to 12. Option D will be the answer. Now I am going to explain another important concept which you are going to apply for solving the questions. Fundamental principle of counting. The first one I am going to consider, it is addition. Okay, first one, it's addition. Consider that there are 2 tasks, task 1, task 2. Let me say task 1 can be done in m number of ways. Listen carefully. Task 1, I can do it in m ways. Task 2, I can do it in n ways. Then task 1 or task 2, it can be done in m plus n ways. Okay, it can be done in m plus n ways. When I use the logic or, it is always addition. When I use the logic or, once again I'm telling this, it is always addition. Task 1 or task 2, if I consider, it is m plus 1. Sorry, m plus n. Now, fundamental principle of counting, multiplication, FPC, multiplication. That also I shall explain. Multiplication. Suppose I am having task 1 which can be done in m ways, task 2 which can be done in n ways, then task 1 and task 2. Task 1 and task 2. It can be done in m into n ways. This is what we discussed in this question. What is that? Ahmedabad to Bhopal, how many ways? Everyone answer. Ahmedabad to Bhopal, how many ways? It was 4. Bhopal to Delhi, how many ways? Ahmedabad to Bhopal and Bhopal to Delhi. So it is and. And when it comes, it is multiplication. So it is 4 into 3, that is equal to 12. 4 plus 3, Allah, it is 4 into 3, that is equal to 12. Be aware of this. I'm going to use this n number of times in team selection and all. I will be using this and logic or logic multiple times. So please be aware of this and take notes. So for question number 4, FPC addition and FPC multiplication, both I have covered. Again recall, task 1 or task 2, it is m plus n. Task 1 and task 2, it is m into n. Okay, so that is taken care. Now, let us go to the next, that in the explanations that I have shared with you, which are those 12 ways that is actually presented here. So you can just see it and verify it. Okay, let's go to the next question. How many different signals can be formed by arranging 3 out of 6 different colors flag in a row? Let me tell you how many flags will be there in that given row. Please answer, how many flags will be there in that given row? You are going to use 3 flags. Yes or no? You are going to arrange 3 flags. So I am putting 3 dash here. The first position can be arranged with any one of the 6 flags. So there are 6 ways of dealing with the first position. Then the second position, please tell me how many ways you can take care of the second position. 5 ways. The third one, it can be placed in how many ways? 4 ways. The task is complete only when you position the first one and the second one and the third one. This mind voice should be there when you are attempting these questions. The first position and the second and the third, only then the task is over. So it will be 6 into 5, 30, 30 into 4, my answer is 120. Another way of looking at it, there are 6, you have to arrange 3. Arrangement means what? It's permutations. So my answer is 6p3. Out of 6 available, I have to arrange only 3 to make that communication happen. So it is 6p3. It will be. What is 6p3? 6p3 is again 6 into 5 into 4. That way also you can handle this question. Okay. But my point is, you have to take care of 3 positions. 6 ways of taking care of the first, 5 the second, and 4 the third. 6 into 5 into 4. 120. Let us go to the next question. If there are, okay, the number of ways in which 8 people can be seated around a circular table. Imagine that there are n people. If you want to arrange this n people around a table, the number of ways, it is n minus 1 factorial. Okay, circular arrangement. The number of ways, linear arrangement, it is n factorial. But as far as circular arrangement is concerned, it will be n minus 1 factorial. This point you should note. If you have got n people can be seated around a table in n minus 1 factorial. In this case, what is the value for n? It is 8. So my answer will be 8 minus 1, 7 factorial. This is my final answer. This is for question number 6. Now let us consider question number 7. Here, from a group of 10 people, in how many ways a selection of 4 people to be made such that a person is always included. It is all about selection. Selection means what? Is it permutation or is it combination? Combination. So 10 people are there, but one person is always included. Nepotism, I would rather call, because that person is anyway there in the team. So what is your task? Your task is to select remaining 3 from how many people? 9 people listed. Are you getting me? Because one person is already there. So practically you need to select 3 more people from 9 people available. My answer will be 9C3. You can evaluate what is 9C3. That will be our answer. Now consider a particular person is always excluded. Some kind of a bias. One person is never going to be there in the team. So can you please tell me what is your task? You have got 9 people available with you. From that 9, you have to select how many? 4. So you have to select 4 from 9 available. My answer will be 9C4 in this case. Please evaluate what is 9C3, what is 9C4. You can see for the first question, it is 84. And for the second question, it is 126. These are the respective answers. All right. Let us go to the next question now. You are considering 6 Maharashtrians, 4 Punjabis. The committee strength it is equal to 5. In how many ways it can be done if the committee consists of at least 2 Punjabis? So altogether you have got 6 Maharashtrians and it is given 4 Punjabis. Okay, 6 Maharashtrians and 4 Punjabis. That's what is given. That's a strength. So at least 2 Punjabis. So Maharashtrian, Punjabi, at least 2 Punjabi, committee strength is 5. So let me start like this. There are 2 Punjabis. How many Maharashtrians then? No, 3 Maharashtrians. So that 3 plus 2 equal to 5. This is a possibility. Or what is the next possibility? 3 Punjabis, continue. 2 Maharashtrians. Or one more. All 4 Punjabis and 1 Maharashtrian. Did you get me? So the team committee can be like 3 Maharashtra, 2 Punjabi, or it is 2 Maharashtrians and 3 Punjabis, or 1 Maharashtrian and 4 Punjabis. Is it fine with you? So here we can see my answer will be 6 available, right? From that you have to select 3. And 4 available Punjabis, you have to select 2, 4C2. The word or comes here. So what is the mathematical operation? It's addition. Plus 6C2 into 4C3. Again, addition. 6C1 into 4C4. Are you getting me? Is there any confusion here? Maharashtrian and Punjabi will be there in the team. So that is why multiplication. So it comes as 6C3 into 4C2 plus 6C2 into 4C3 plus 6C1 into 4C4. Probably you all might have noticed something interesting here. I have used the fundamental principle of counting, addition, fundamental principle of counting, multiplication, both in the same question. In one case, when the team is there, it is and. When I go for the next possibility, it is or. It comes like that. Is it fine with you? So this brings conclusion to our first question. I request you to please evaluate the numbers and get me the final answer. The committee consists of at most 2 Maharashtrians. There are 6 Maharashtrians and there are 4 Punjabis. Okay, so it is indicated that at most 2 Maharashtrians. At most means maximum 2. So I will say 0 Maharashtrians and 5 Punjabis. It is actually not possible. Can you tell me why? We only have 4 Punjabis in our team. So from that, I cannot select 5 Punjabis. So this option is ruled out. What is the next possibility? 1 Maharashtrian and 4 Punjabis. Or please tell me what is the next possibility? 2 Maharashtrians and 3 Punjabis. Are you getting me? So it will come as 6C1 into 4C4 or, so addition. Chalango, 6C2 into 4C3. Are you getting me? So my answer for this question will be 6C1 into 4C4 or, so addition, 6C2 into 4C3. Evaluate it, you will get the answer. That is for the, see, for me, the logic is more important. Calculation you can anyway do. Okay, so that is for the next one. A committee consists of exactly 2 Punjabis. What about exactly 2 Punjabis? Tell me. It is going to be 2 Punjabis and 3 Maharashtrians. So can you tell me the answer now? 6C3 into 4C2. My answer will be 6C3 into 4C2. Any difficulty in understanding this so far? Okay, if you have got any doubts or something, please park those doubts. I will address the same. Okay, let's go to the next one. The number, okay, read the question. Find the number of 4-digit numbers that can be formed using 0, 1, 2, 3, 4, 5, wherein repetition is not permitted, which means a number used cannot be used again, such that the number is less than 6,000. Okay, the number is less than 6,000, which means it's a 4-digit number I am considering. Agree? The leftmost position, it can be either 1 or 2 or 3 or 4 or 5. Do you agree with me? So I can fill the leftmost position in how many ways? I can fill it in 5 ways. Now, the hundreds, sorry, yeah, the hundreds digit. In how many ways I can fill the hundreds digit? No, it will be again in 5 ways. Agree? It is going to be again in 5 ways. Why? Because I have used up a digit. Listen carefully. I have used up a digit. Say I have used up 5. Then it can be filled with either 0 or 1 or 2 or 3 or 4. 5 ways of taking care of the hundreds position. Then how many ways I can take care of the tens position? I can do it in 4 ways. And how many ways I can take care of the units position? In 3 ways. So what will be my answer? It will be 5 into 5, 25. 25 into 4 is 100. 100 into 3, the answer is 300. So altogether, I can have 300 different possibilities. Is it clear to you? It starts with the leftmost position. I cannot have 0 in the thousands place. Why? Because I am dealing with 4-digit numbers. So it should not be filled with 0. It can either be 1 or 2 or 3 or 4 or 5. So 5 ways you can take care of it. Then comes the hundreds position. I can see it can happen again in 5 ways because 0 is possible there. 1 digit gone, 1 digit comes in. So that is the next one. And then the third one, I can see it can also happen in 4 ways. And finally, 3 ways. The answer is 300. Now the next one is important. They are saying it is even. When I say it is even, based on the context here, units digit 0, otherwise 2, otherwise 4. 3 possibilities you have to take care of. So it could be either 0 or it could be 2 or it could be, or it could be 4. These are the cases. Let me say, if it is 0, then I can fill the thousands position in how many ways? In 5 ways. 1, 2, 3, 4, 5. One of them I can use. How many ways I can take care of the hundreds place? In 4 ways. Because I have used up 0, I have used up 1 digit. So 4 ways of taking care of the next one. Then how many ways I can take care of the tens position? Please answer me. 3. So 5 fours are 20. 20 into 3, 60. If it is ending with 0, I can see that there are 6 possibilities. Is it fine with you? Any doubts? If it is ending with 0, I can see that there are 5 fours are 20. 20 into 3, 60. That many number of possibilities are there. Okay. Let me say it is ending with 2. So I have used up 2. Leftmost position cannot be 0. So how many ways I can take care of the thousands place? Not 5. 4 ways, because 2 is used up. Leftmost position cannot be 0 because I am dealing with 4-digit numbers here. So 2 gone, 0 gone. So 4 ways of taking care of this leftmost position. 4 ways of taking care of the leftmost position. Okay, next one. How many ways I can take care of the hundreds position? Again 4 ways, because there 0 comes in. Are you getting it? I have used up 2 digits, but 0 I have not used 4 ways. So how many ways I can take care of the tens position? 3 ways. So 4 4s are 16. 16 into 3, 48. If I am considering the number that is ending with 4, it will be again 4 into 3 only, because same thing repeats. So 48. So can I know what will be the final answer now? 60 plus 48 plus 48. What is the answer? 216, right? Or 156. What is the answer? 60 plus 48, 108. 108 plus 48, option C, 156. The answer is option C, 156. Is it clear? Okay. It could end with 0, or it could end with 2, or it could end with 4. There is no 6, there is no 8. Yes. Huh? What happened? Totally. I will explain it at the end. Time is not there. I will explain it at the end. Okay. Let's go to the next one. The number of ways of arranging 3 boys and 3 girls in a row, so that boys and girls, they sit alternatively. The arrangements possible are, it could start with a boy, then a girl, then a boy, then a girl, then a boy, then a girl. So you can see that boys can be arranged in 3 factorial ways. Girls can be arranged in again 3 factorial ways. So altogether 3 factorial into 3 factorial. That is what, when it consider, we start with a boy at the left end. But there is one more possibility. Can anyone tell me what is that? There could be a girl at the left end, then a boy, girl, boy, girl, boy. That is again going to be 3 factorial into 3 factorial. Are you getting me? So total number of ways it will be 2 times 3 factorial into 3 factorial. 3 factorial, you know, it is 3 into 2, 6. So it is 6 into 6, 36 into 2. Okay. So I can see that this is nothing but how much? 72. That is going to be the answer. Is it fine? And then the row start with a boy and it ends with a girl. In between, what combination? I don't care. But it starts with a boy and it ends with a girl. So can you tell me leftmost position, how many ways I can fill it? 3 ways. One of the 3 boys can sit at the leftmost position. It may be B1 or B2 or B3. I don't know. Leftmost position, 3 ways. Rightmost position, it can also be filled in 3 ways. So if you observe, I have used up 1 boy on the leftmost position, 1 girl on the rightmost position. How many students are remaining now? 4 students are remaining. Those 4 students, there is no restriction. However, they want to sit in the 4 available place, they can do that. That will happen in 4 factorial ways. So total number of ways will be 3 into 4 factorial into 3. Did you get me? That will be the answer. 3 ways of taking care of the leftmost, 3 ways of taking care of the rightmost. In between, it is 4 factorial. Arranging 4 from 4 available, 4 factorial. That value, when you calculate, it will come as 216, as you can see. That is for the next question. Last one, no 2 girls sit together. So here the condition is only with the girls. Boys, there is no problem at all, right? So the 3 boys, I'm going to arrange them in how many ways? Can you tell me? The 3 boys. Let us first deal with people who don't have any conditions. How many ways I can arrange the 3 boys? In 3 factorial ways. Now let us think about the girls. There, the girl may be placed here or here or here or here. Are you getting me? 2 boys can be together. 2 girls cannot be together. That's all. So in any of the positions, you can ask the girls to occupy. There are 4 places available and you have to arrange 3 girls. So my answer will be 4P3. There are 4 places available. Place 1, place 2, place 3, place 4. You have to arrange only 3 girls. So my answer will be 4P3 into 3 factorial, which is 4 into 3 into 2, entire thing into 3 factorial. That will be my answer. When you do the evaluation, it will come as 144. Option D will be my answer. Okay, so that is for 14, 15 and 16. And the last 4. How many words can the letters of the word meadows be arranged? So that it always starts with A. MEADOWS. It always starts with A. I can see that meadows, MEADOWS. There are altogether 7 letters. Out of the 7, E, A and O, there are 3 vowels. Okay, and there are remaining 4 consonants. Is it clear? So it always starts with A. So 1 letter used up. So I can say this position can be arranged in 6 ways. The next one 5, then 4, then 3, then 2, then 1. So my answer will be what? 6 factorial, which is 720. That is for the second question here. It never ends with E. What is the logic? That I shall quickly tell you. The total arrangement, you know, it is equal to 7 factorial. In this 7 factorial, I can see that altogether there are 6 factorial ways in which it is going to end with E. Do you agree with me? Because the same thing only 1, 2, 3, 4, 5, 6, 7, that it ends with E. It will happen again in 6 factorial ways. So what I am doing here is, from total number of ways I can arrange it, I am going to exclude the number of ways in which it is always going to end with E. Then what is my result? The result is the number of arrangements wherein it is never going to end with E. From totality, okay, this is what the totality it is all about. And there is a situation wherein that it is going to end with E. Okay, end with E. So from totality, when you exclude this possibility, then what are you going to get? The number of arrangements wherein you can see that it is not ending with T. Are you getting me? Not ending with E. I mean, are you getting it? That is the logic here. So 7 factorial minus 6 factorial is what you will do. So that will get you the answer for the next question. Now the next one, the last, the penultimate one, in which the vowels occupy even places. So 1, 2, 3, 4, 5, 6, 7. Position 2, position 4, position 6. The vowels can be arranged in 3 factorial ways. Do you agree with me? It may be here, or it may be here, or it may be here. Somebody is changing it? Okay. It may be in 2 or 4 or 6. So vowels can be arranged in 3 factorial ways. Can you tell me in how many ways you can arrange the consonants? That can happen in 4 factorial ways. So total number of arrangements happening, it will be 3 factorial into 4 factorial. 3 factorial into 4 factorial when you do, you can see my answer will come as 144. So that will be the answer for the last question. So I have done 18, I have done 19, I have done 20, 17 is pending. So that I will explain now. Can anyone tell me with what logic I can explain that 17th one? They do not contain all the consonants together. What I will do is, I will first consider the total arrangements. What is the total arrangements? Total arrangements. Total arrangements, it is 7 factorial. Next step I am going to do is, I will consider the number of arrangements wherein the consonants, tell me, consonants are always together. Okay, so consonants are always together means what? There are altogether 3 vowels and 4 consonants. You take all the 4 consonants as a single unit. The 3 vowels as 3 distinct units. So you have 4 units now. 3 vowels and then 4 consonants as a single unit. Altogether 3 plus 1, 4 units you have. Agreed? So they can be arranged in 4 factorial ways. 3 vowels and consonants as a single unit. They can be arranged in altogether 4 factorial ways. And you can see the 4 consonants between themselves can be permuted in 4 factorial ways. Between themselves, the arrangement can happen in 4 factorial ways. So my answer will be 7 factorial minus 4 factorial into 4 factorial. Did you get me? So that will be the answer for our first question. And we can see when you do it, the answer will come as 4464. So option C, that is going to be the answer. Okay. So with this note, we have explained all the 20 questions. You may ask your questions or queries now. I shall answer them. With this, we are closing the conceptual inputs part. Okay, fine. Thank you.